Hey there, Course 3 Math students. Mr. Rising here. Hey, this is the Data Analysis Performance Assessment. It is a test, a project, and what I'm trying to get you to do here is to collect real data, to plot it on a scatter plot, and then to create an equation. These are the standards that we're focusing on in this chapter in the book, Chapter 9, because making sense of data, trying to build equations that we can predict what's going on with is so important. So I just wanted to take a little time to go through what I'm trying to get you to do here. So there's two parts to this. Let's just focus on part one. Collect 6 to 10 bivariate data points. Bivariate means it has a independent x component and a dependent y component. Like, for example, time and temperature, or time and distance, or time and height. I mean, it doesn't have to be time. There's a variety of things, and I'm going to give you an example here. I need you to identify the x-axis and the y-axis, the independent and the dependent variables. Use a ruler to create a scatter plot. Make sure you have a good scale. Here's a little link to a video. Make sure you give it a title. Label your axes. And then you're going to estimate the line of best fit with a ruler, and then create an equation for the line of best fit in the form y equals mx plus b, and then predict a value that was not included in the original data set. So for this example, I have chosen to have fun because no one's in the classroom, and I am shooting rubber bands. So my goal was I'm going to take a rubber band, click, 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 there we go, got a rubber band here, have a ruler here, and what I'm doing is I'm stretching I'm stretching the rubber band and pulling it back. And you probably can't read that on my camera. Maybe you can, I don't know. And basically what I'm saying is I'm pulling it back. I'm going to use that stretch. That is going to be my independent x-axis. The dependent is when I release it at the same angle every time. How far is it going to go? Well, the first thing I did, so I'm going to collect my data. I identified my points. The first thing I did here, I don't know if you can see that or not, is I made a table. There we go. That looks pretty good. And it says basically how far did I pull it back? 2 inches, 3 inches, 5 inches, 6 inches, 7 inches, 9 inches. And then I recorded the distance that it shot across the room. Cool. Now I'm going to make a scatter plot. So what I'm going to do here is I'm going to just tilt my camera down and show you how to do it. And I highly recommend using, I don't know if you can see that or not, but I think you get how to make a scatter plot. I'm going to use a pencil. Actually, I'll use my marker so you can see it better. And I've made a nice scale here. You can see that I used a ruler to make my scale. Everything's nice and uniform. I've got a label at the top. I've labeled the chart. I've got a label on the y-axis, distance in feet. The x-axis is labeled, right? Stretch in inches. And then basically I'm going to plot these points. And I'll just go ahead and do that right now. I'll do it upside down just for you. 2 is 7. It looks like I'm halfway between 6 and 8. 3 went to 10, right there. And I can use my ruler to be, and I should use my ruler. I should be as accurate as possible to do this. 5 went to 15. So 15 is right in between the two. 6 went to 18. Interesting, that's like a slope of 3 roughly. We'll see, but then it's definitely not a perfect straight line, I'll tell you that. 7 is 19, so that one for some reason didn't go nearly as far. I'm actually pretty close to that. And then 9 was 22, and then 22 is right over here. Okay, right there. And now that I've done that, I'm going to take a pencil or a pen. I'll use a red pen. I don't know if it'll show up on my video here. I'll hold it up when I'm done. And I'm going to make a line, and I'm going to try to see if I can hit as many of those points as possible or slice right between them. Bam. Did it. Right. So now what I'm going to do, I've estimated the line of best fit with a ruler. Now I'm going to create an equation for the line of best fit and predict the value. Well, how do you do it? Don't forget, you can watch, if you haven't already watched the next lecture, it's a great way to really analyze these things. Basically what I'm saying is the y-intercept is the point where it crosses the y-axis. So right there, it looks like that's about 3. So in my form, y equals mx plus b, my y is 3, is plus 3, positive 3. Dun, dun. Now I need to figure out the slope. Well, how do you find the slope? You take 2 points on that line, and you use the slope formula. So I can see right here, I have a point. Oh, this is fun. I'm trying to work up there. There's a point, has a coordinate, and then up here, there's a point, and it has a coordinate. Those points, let's see, were 2, 7, and 9, 22. And when I look at those 2 points, I can use my slope formula to figure out the slope. The slope, m, equals y2 minus y1 over x2 minus x1. And let's see, 22 minus 7 over 9 minus 2. And you can see, hopefully you can see that just fine. You can see where I'm actually getting those values from. If you need to pause the video, go ahead. Now I'm going to simplify that fraction, and I can work it out into a decimal or a fraction. 22 minus 7 is 15. 9 minus 2 is 7. I'm going to just use my calculator. What the heck, I'll do it as a decimal, no big deal. 15 divided by 7 is 2 1/7, or 2.1. My slope is 2.1. That means for every inch I pull the rubber band back, I would expect it to shoot 2.1 feet. All right, so let's finish the problem. Let's put it in an equation. My new equation equals y equals 2.1 x plus 3. And now what I need to do is predict a value that was not included in my original data set. Well, man, I'll tell you what, if I could plug in, if I had the rubber band and I could stretch it more than, let's just use a number here. Let's say 8, because I didn't actually do a measurement for 8. So I'll plug 8 into my equation. So y equals 2.1 times 8 plus 3. Dun, dun. And when I do that on my calculator, 2.1 times 8 plus 3, I get 19.8 feet. And I have successfully collected my data, made my graph, written everything up, and now I can take a picture of this and submit all this work. I could make a short video of how I did it. I could upload a file, whatever you need to do. Hey, that was an 8-minute video. It was an 8-minute video. I hope that helps. And then if you're looking for project ideas, things to consider. Snow cover. Take an area. You can read through these. They're all posted on Canvas. Look at the snow cover in your yard or place. Look at plant growth. A lot of plants are coming out of the ground right now. Rubber band stretch versus weight. This is a really cool lab. You can click on this link and it'll give you more information. Cooling water is a great thing. You need a little supervision in a boiling kettle, but it's a great way to graph points. Do something on the coronavirus. Look at the number of cases over time, or the new cases per day. Look at it by state, by country. That's a really interesting topic right now. Look at the stock market. What's been going on in the stock market over the past 3 months or whatever, or 6 days over 3 months, or whatever interests you. It does not have to be one of these 6 choices. I'm just trying to give you ideas to get you curious into your world, how you can collect data and analyze it. Hope that helps.